Let's maybe get started. Is my screen visible to everybody? Kanpat, is my screen visible to you? Because I'm seeing a failure on my screen. I don't know if it is visible or not. Is my screen visible to everybody? Folks, a little bit of feedback would be appreciated. Is my screen visible? Can anybody speak up? Okay, perfect. So are you seeing a slide called cloud computing? Okay, I'll assume that's a yes, and we'll get started. So good morning, everybody. Sorry for the delay. There was a little bit of technical glitch to start with. I apologize for that. So we'll get started with this topic today called cloud computing. I'll first do a quick introduction of myself. My name is Karthik Srinivasan, and I have maybe around 25 years of work experience in the field of software engineering and in domains like supply chain management, in mobile security, and cybersecurity in general. So this is a topic that is very close to my heart, and I've gone through a journey where in multiple organizations we pivoted from a technology stack which was pretty much on premise in house to a stack which is completely on the cloud. And what we will try and do is take some learnings from that entire journey, which was multiple years, and in fact, in some cases, even decades, to try and give you a sense of what is the value that cloud computing brings in. All right. So let's maybe talk about the evolution of tech. And I think if you have been on other Satcam sessions in the past, there is a series that we do about evolution of technology, and we'll just do a continuation of that session here as well, where we start with talking about these computing devices called mainframes, which were essentially brought in 1970, 1980, that decade. And these are extremely reliable machines, very large machines with central processing power. Uh, uh, they have like sort of dumb terminals that you connect to be able to access this computing device, and then you submit work to this entire set of large processors, right, that are sort of accumulated in this picture over here, right? So there are many racks, and it is a large computing resource, very expensive. However, it is extremely reliable, extremely high throughput, right? And for mission critical stuff, this is, I mean, which has to have like maybe zero downtime. It cannot even go to 99.9999 availability, 59 availability, but more than that availability. So 7 nines, 9 nines is the kind of availability that these devices were designed for. So this was the original sort of evolution of technology, right? Where we had large devices and very expensive devices to maintain. Let's just move maybe a decade or 20 years later, and what we see is a new sort of paradigm emerging, where there is this thing called the client-server architecture that began. Now, the way this is different is that, yes, you will still see this concept of central server in this picture, which is very similar to the concept of mainframes. But the interesting thing is the clients had some amount of computing power. These were not dumb terminals like the mainframe days. These had significant or reasonable local processing power, could connect to the internet on the dumb terminal side, connecting to mainframes. The only thing you could do is connect to a mainframe, right? In this world, you could connect to the internet, you could get connected to a server, and then do work that could be distributed between the server as well as the client, right? So this is a paradigm shift in the way the computing works. Everything used to be centralized. It is starting to get a little bit decentralized. So you can start seeing semblances of the modern ways that we do computing today. In the 1990s, This was a slightly different model. There weren't, I mean, the devices that we are talking about here are nowhere in the same league as the ones that we have today. But this is the onset of this new paradigm shift where there is computing that is decoupled, decentralized, and there are clients and servers that work in tandem to get some work done. The third kind of evolution that happened from the 2000s to now is that uh, as organizations started understanding maybe client server architectures, etc., they started to realize that you couldn't have a simple server client architecture anymore. And so what they started doing is investing in this thing called server clusters or racks, right? And again, like you'll see similarity in the sense of like what you see in the first picture to here. So essentially what is ending up happening is that it is client server, multiple clients and multiple servers in this kind of a model where you have enterprise-owned computing resources. Your organization or the enterprise is deploying various servers in their network, right? And in many cases using capabilities like virtualization, etc., to make that management of these servers simpler. So because these are hundreds of machines that are sitting inside a room uh, called the data center within the enterprise. So you would want to have some kind of a management plane, which virtualization technologies like VMware, etc., started to provide. Right. So typically a deployment on this environment would be automated. You would have web applications that are talking to any kind of software that is deployed on these servers. And then remote clients like this picture, right? Could be a laptop, for example, instead of a desktop over here, would connect to these set of computing resources. So this is the third phase in sort of the evolution of technology. The current state, right, and this is the picture of the world today, is that there is multiple organizations like Amazon, Google, and Microsoft that provide what is called as, and including IBM as well, that provides a what is called as a cloud service. And this cloud service provides you with multiple things that you can make use of to stitch together the software you need. So in this world, in these worlds, typically all the conversations that we have been having were for infrastructure, but these clouds are a combination of multiple things. Includes infrastructure, includes software, right? And many things around software as well. So it is not necessarily just limited to uh, the infrastructure side of things, like for example, network or storage or CPUs or memory, etc. It goes way beyond those aspects to ways in which you can ease the simplification of your deployment of the software into the cloud. You can potentially leverage the goodness of this cloud, which is also a platform as a service, right? And so you see this XaaS. This is X could be infrastructure as a service called IaaS, or it could be platform as a service, which is maybe the presence of a database that you can just spin up on the cloud and start making use of for yourself. Or it could be SaaS too. And there are many services that uh, Azure and GCP and Amazon provide. So, for example, Azure provides Office 365, which is a SaaS product that helps your enterprise become more productive, right? So the Excels and PowerPoints and Outlooks and OneNotes of the world, these are all sort of SaaS services that Azure and Microsoft provide. So the idea here is that this is a complete unit where infrastructure, the platform, and software are all available for consumption. And the things that make it differentiate with the previous three sort of generations of technology from a computing perspective is the fact that this is extremely scalable. It is globally present, and it offers extremely low upfront costs. So that's the whole sort of difference between the shifts from where we started and where we are today. Let's maybe drill down into the details of what cloud computing really is, right? And first of all, I think we have to ask ourselves, what is cloud, right? And the answer to that essentially is that you can think of cloud as a place where you have vast amounts of computing resources available to you, not just computing resources in terms of infrastructure like CPU, RAM, disk, and network, but also computing resources like software services that are available across the world in many, many regions and highly available everywhere. So that even if there is a failure in a particular region or a data center, you have the service available somewhere else across the world, and it transparently sort of shifts the workload over from one place to another. So if this definition matches up, you could say that you are entering the realm of cloud computing, right? So cloud computing in general is the technology and processes that are then used to store, manage, and process the data in the cloud. So if you have all of the CPU, RAM, disk, network, and some software services available across different regions of the world, then the technology that is used, or the processes that are used to store, manage, govern the data in the cloud, is essentially what is cloud computing. Okay, so I hope this is clear to everybody. And feel free to stop me and ask a question if you're not clear about any concept. Okay, right. Let's talk about the advantages of cloud computing, and I think one of the most commonly used advantage is the fact that a cloud service brings you instant and unlimited scalability, right? So you would have always heard about this term called elastic cloud, and many companies actually will market themselves as having services that are elastic. So what that elastic means here is that you have unlimited scalability in terms of if you require more computing power, a larger storage, more memory, etc., the capability that is provided by that cloud will allow you to scale up or down as needed and instantly, right? So that's one of the key advantages that is touted for cloud computing. The other advantage that is often called out is that you can access the cloud resources from anywhere, and it could be from the internet anywhere, right? Typically, when we look at the model where the enterprise deploys its own data center, etc., the only way you can access some of those resources is from within the enterprise. So if you are within the office network or your enterprise network, only then would traditionally some of these services be accessible to you. But when it is on the cloud, the advantage is that when you're on the go, you are on the road, you may be flying in an airplane, etc. Anywhere where you're connected to the internet, essentially is a gate for you to get into making use of the cloud services that are available to you. So that's the value proposition that is provided by cloud. The third very important value proposition is that it is very cost effective, right? And the reason it is cost effective is because as a cloud, from a provisioning standpoint, from the perspective of pooling in resources to be able to do things very cost effectively, etc., the whole sort of business revolves around optimization and optimization of costs. Because everything is pooled, and every sort of purchase that is made for, let's say, ordering computing resources like CPU, memory, RAM, and building up the data center is usually done in bulk. Therefore, the whole business of cloud computing is extremely cost effective, and also the fact that it is extremely measured in terms of how many seconds of use did you make use of a particular service, a particular CPU, a particular database, etc., gives you fine-grained control of how to manage your costs. So therefore, it becomes very cost effective. The fourth reason is global presence, right? So imagine an enterprise wanting to set up their presence globally, and there are many reasons why you would want to do global presence. So one of the reasons is that, for example, if you are the user of a mobile application that talks to a data center, and that data center is 10,000 miles away from you, uh, invariably you will see that there is this thing around network latency, performance related problems, etc. The app is a little sluggish. So all of these considerations are very important to imagine why you would need global presence. And if you need global presence, it means that the traffic will be routed to the nearest regional data center of wherever you are. And so, for example, if I have a global service that is deployed in the US, in Europe, and in APAC, and I try to access that service from the Asia Pacific region or India specifically, then transparently I should be routed to the India data center, because the other two data centers are maybe thousands of kilometers away from me. And no matter how fast the network is, etc., there is a lag in trying to take a request that originated from my phone to that data center and get the response back. So even if it is a few seconds of delay, then you would actually see that performance delay starting to add up over a period of consistent usage. So that's one of the reasons why you need global presence. The other reason why you need global presence is also because you want the service to be very robust when it comes to, let's say, a disaster, a natural disaster. So maybe a few years back, there was a data center in Chennai that got flooded, right? And what happens when you encounter things like that? So the data center is completely flooded. Obviously, they have to shut everything off, because you cannot let power inside a data center where water has come in because of a natural calamity. Then how do you manage it? And so the fact that some of these data centers are globally present, they have backups in various parts of the world, and they can easily restore the service from one region to another, is one of the critical reasons why global presence is needed, and critical reason why cloud computing is so much more successful, because this kind of a infrastructure management is very difficult for enterprises to do, right? So if you were to do this yourself, it would require a lot of effort and a lot of cost. But because cloud computing companies are doing this at a very large scale, and doing this for many thousands of customers, they are able to invest and get some of these kinds of processes and technologies going, which in the case of a normal an individual or an enterprise would be very difficult to achieve, because their core competencies are elsewhere. Fault tolerance and high availability. So one of the other reasons why some of this stuff is from a cloud computing perspective is very successful is the fact that uh, being on the cloud gives you inherent fault tolerance and high availability. So what do I mean by that, right? The I mean, all of this stuff is based on hardware, right? And we started off by talking about CPUs and memory and storage. Many of these things are hardware devices, right? And rely on hardware devices, and hardware can fail. So If you were to set up infrastructure as an individual or as a business that is fault tolerant and high availability, it needs a tremendous amount of effort to put together something that will tolerate a hardware failure and still continue to work and be highly available, right? So imagine a IRCTC service, and let's say one of their CPUs just burns up, right? And it happens quite often. So CPUs are chips, right? They produce heat. Sometimes, I mean, they also have a lifespan. So sometimes what can happen is that the CPU just goes kaput. And imagine a site like IRCTC that has to be up when somebody is booking a rail ticket, an urgent rail ticket on Tatkal. Now, if you don't have an element of fault tolerance and high availability built into the infrastructure and to the software services that are deployed on it, then you're going to see an outage, right? And I mean, when you click book now, suddenly there is going to be an error that is thrown on your screen, and you're not going to be able to make a booking. And that travel was very urgent for you and very important for you. But the inherent nature of this deployment, for example, if it is not tolerant or highly available, will be that there will be business dissatisfaction, right? So you, as the consumer of that business, is going to be very frustrated and maybe move to an alternative either option or to a completely different way to get this work done. And maybe you will go to an airline site and book an airline ticket for yourself. So this is an opportunity loss, right? So cloud computing gives you capabilities that you can leverage to become extremely fault tolerant and highly available. So these are the main sort of advantages. The last one is partly something that we spoke from a cost effectiveness standpoint. The reason the cost effectiveness is in place is really because cloud computing is dealing with economies of scale. And what I mean by economies of scale here is that it is taking into consideration the needs of multiple enterprises, multiple individuals, multiple types of enterprises, small, medium, large, and many of these in number, and making some kind of estimations on what does the need look like, pre-provisioning and bulk buying some of those capacities upfront, so that when it is actually needed, it is available to these enterprises, individuals instantly. And so because they have purchased this in bulk, obviously this gives economies of scale, right? So in short, I think what I want you to take from this slide is that these are all very important aspects that if you were to deploy your software, you would want to think about. And if you look at cloud computing, what it does is that it lets you focus on doing what you do best. I mean, if I was building a stock market analysis app like maybe Zerodha or Grow or something like that, it lets me focus on that side of the work and forget about economies of scale, fault tolerance, global presence, cost effectiveness, access from the internet, unlimited scalability, etc. Because I can assume that this will be given to me by the cloud of my choice, and I just need to focus on getting my app right, my business right, and making the experience of purchasing that stock and analyzing that stock a little better. So, so the idea behind cloud computing is essentially focus on what you do best and implicitly forget the rest of the problems, right? And leave it to the cloud, right? So I think I'm going to open up the conversation to maybe a series of questions like this, which will essentially make you think a little curiously, little bit inquisitively, etc. So I'm going to ask this question. So we spoke about this whole thing about elastic nature of the cloud, right? And I said instant unlimited scalability is elastic. Why do you think that word gets used so often? So what makes that word stick so easily in people's heads? Anybody who wants to take a stab at the answer? I would really appreciate if this is a two-way conversation. So please speak up and you can share your thoughts. Anyone? No one? Okay. So I think we spoke about this, right? So as businesses grow, they may need more capacity, more computing horsepower, etc., etc. And essentially, the scalability side of things was the fact that you can, as a business, if your business is growing, you can scale it up. If your business is not growing as much as you originally thought, you can scale things down. And essentially, the power to be able to do that instantly on the cloud is why this is called elastic. Think of it in the sense like how you would look at a rubber band, right? You can, if you apply a little bit of force and you stretch it, you can horizontally stretch it to whatever levels you want to stretch it to the limits. But then you can also bring it back if you stop sort of sustaining that pressure. So that's the reason there is this elastic term that is made use of, that you can start with a certain size, extend it, and keep sort of the elastic stretching as you feel the need for it to expand. But then also have a way that you can, if you expanded, you can also sort of retract to the original state if need be, in a very smooth and very instant manner. And that is why this word elastic is very sort of closely tied with cloud computing. The second word we spoke about is global presence, right? Essentially, uh, I can give you two reasons, right, why this is helpful. Disaster readiness. If there is a disaster, I want to be able to shift my operations to some other country and start my business. And then there are also things like data residency and regulations, right? Maybe governments are forcing you to make use of data centers within a specific country or a specific region. What else do we think is the reason for global presence? We briefly touched upon it a little earlier, but why do you think global presence helps? And it is, I mean, obviously very difficult for enterprises to do this global presence themselves. And so cloud computing becomes very easy for us to deploy our software globally. But what are the other reasons why global presence helps? Anybody? No one? Or is somebody answering on the chat that I'm not looking at? Okay. Anybody? No one? Okay. Yeah. So one of the reasons we spoke about is the fact that if you have global presence, you can reduce network latencies. So, and network latencies are very important to bring in good experiences to your consumers, right? If you are building a software and it is very sluggish to load, it could very well be because a request that you're making on the software goes all the way 10,000 kilometers or miles away, and the responses are coming back. It is a significant latency factor. So if you want to reduce latency, you need to be able to have a global presence and very silently be able to route your consumer to the nearest local point of local presence, whichever country or region is closest. The traffic will be routed to that particular data center, right? So that's one of the reasons why global presence is very key. Okay, let me move this to. Yeah. So economies of scale. What does economies of scale mean? We covered this a little bit, maybe 3-4 minutes back. Can somebody maybe help me take the concept one step further? What does economies of scale really mean in the context of cloud computing? No one? It's a very quiet crowd today. Usually there are lots of questions. No one, is it? Okay. All right. So let's go further. So there are two considerations, right? We spoke about both of these, that there is the supplier side economics, which is that the supplier, let's say an Amazon or a Google Cloud or a Azure, they will standardize hardware. So they will basically say, look, this is the kind of configuration I need. I need a 64 GB machine um, with X GB of RAM, with a processor that is three gigahertz, etc., etc. And essentially, this is the configuration that they are standardizing, and they will have thousands and thousands of such servers that they will procure, right, and make it available. And so they will have a set of maybe standardized configurations, one which is optimized for memory related computing, one that is optimized for CPU kind of computing, where a lot of processing is happening on the CPU, right? Or there could be combination of both, right? And so those kinds of standardizations, if the cloud provider does, then what's happening is that, again, you basically want to order a large number of such standard hardware, and therefore there is bulk buying. And bulk buying, as you always know, is always cheaper than going to a retail store and buying whatever you want to get. So if you buy in bulk, there is obviously discounts available. So that's what helps the supplier, which is an AWS or a GCP or an Azure. There is also this thing called power cost savings, and the fact that these companies decide on data center locations very carefully, right? So they will usually try and pick a data center location to a place which is very close to, let's say, an electric grid or a power uh, generation unit somewhere, right? Or in many cases, they are generating their own power. And you may be surprised, but Google has its own generators, right? They have their own hydroelectric power generation facility in the US that they leverage for cheaper power costs, right? And then the fact that they invest a lot in automation. So, for example, everything that you interact with in AWS or a GCP or in Azure is all based on, let's say, command line tooling or APIs, right? And the fact that you can write those automations yourself to maintain, repair millions of instances that are deployed in your environment makes the supplier side economics extremely good to sustain. At the same time, there is also the consumer side economics, and because all of this stuff has happened, right, and demand aggregation has happened based on the standardization, etc. The company is able to forecast what is the kind of compute power that is going to be needed for the next 6 months, for the next 1 year, etc. And that is an aggregated demand that is for a company X, company Y, company Z, maybe thousands of such companies. And so when you aggregate the demand in such a large scale, obviously the economies of scale is going to kick in, right? So pooling is a very important concept that these companies make use of, and they're basically saying that you can have these instances reserved for you, or you can have these for these particular time of the hours during the day, and then some other person can bid for this compute at a period that they need it. And all companies will have their own sort of timelines when they need certain activities to happen. So, for example, if you're looking at, let's say, a Flipkart, right? So their biggest use of these cloud resources probably happens during the day. But do you think that people are buying as aggressively on Flipkart from midnight to 8 a.m.? No, they are not, right? So people are not even looking at Flipkart app at that time and buying things, unless, of course, there is a sale, a Diwali sale that kicks out at 12 a.m. midnight or something like that. Nobody generally is trying to do active buying on some of these websites, and so there is a possibility that during 12 a.m. and 8 a.m. The computing resources that are used by Flipkart don't need to be reserved. They can be sort of shut down, and that pool of shutdown devices can be made available to somebody else who's probably doing a lot of their things in the night. So, for example, this could be, let's take an example of who's probably working through the night. This could be companies like courier agencies that are doing a lot of logistics planning, etc., over the night, so that in the day they can do their deliveries better. So if those kinds of companies are able to use the same set of resources that if Flipkart gave up during the night hours, then that's win-win for everyone, right? So you are essentially looking at time-dependent traffic and using pooling as a solution to get more benefit out of the hardware that is being deployed. So that's one of the reasons why consumer side economics works very well. The other aspect is, I think, from economies of scale perspective, from the consumer standpoint, right? If there is a company that sees a exponential growth, right, for them to start addressing that exponential growth through technology means that in very some short amounts of time, they need to start provisioning or buying capacity to run their own data center, and that's very difficult to get because none of these suppliers will have machines that are available to them on demand. You place an order, and the order will come to you in 3 months, 6 months, 9 months. But you need that amount of computing horsepower now. And what are you going to do at this point? So the only answer in many of these cases tends to be cloud-based computing. And that's why this whole thing works so well. So you have to take that away, that there is both supplier side economics as well as consumer side economics that is at play over here. And economies of scale is what makes the deal sweet for both sides. The supplier also wins, the consumer also wins. Okay, right. Now, this picture is a picture that architecturally talks about a typical web application and how it interacts with various different components. So on the left, you see a user or a client who's basically connected to the internet, and through the internet, he's accessing a web application. The web application is in this blue box here. The web application has usually got typically a front end, which is where the user is engaging in terms of filling up a form or signing in or et cetera, et cetera. And then there is a backend which is doing all the business logic for him. So this backend is interacting with the front end to take the requests that the user filled up and essentially execute whatever that request is, so that a meaningful response is given back to the client. Now, as part of this backend activity, there is multiple things that can happen. You may be interacting with network, you would be interacting with storage, databases, etc., etc., and then potentially even external integrations, right? So to basically say that after you have done certain things, I want to be able to send a email to the user, or I want to be able to trigger a WhatsApp message that goes back to the user to say, hey, you signed up on my website. So that's what this purple thing is in terms of external integration. So this is the flow of a very typical web application. If you take Satkam's architecture courses, we also talk about the 3-tier architecture that is three-tier architecture, and as a specific implementation of n-tier architectures. And when we go through that session, we talk about the exact same thing. So more details about all of this can be found when we go through the architecture sessions. But just imagine that this is a typical architecture, and this is how most, if not, I would say maybe 95% of the web application design or architecture looks exactly like this. All right. So the interesting thing is that if we were to visually illustrate the fact that there is high availability, redundancy built into the system, what you're essentially seeing is that you could be potentially taking requests from multiple users or client. It could go to multiple instances of the same front end that is deployed within the cloud. It could then talk to multiple deployments of the same backend that essentially does all the business logic. And this backend can then talk to multiple storages, right? So in terms of redundancy, what's essentially happening is that there is, if one fails, for example, one of these presentation layer fails, there are other two that can service the request and make sure that the system is fault tolerance. So that's basically what redundancy gives you, right? Or if too many users just suddenly log in because Flipkart launched a Diwali sale, you have adequate amount of capacity in terms of services that are deployed that can handle that load, to be able to take that request and process it and do whatever is required to essentially place the order and get me the stuff that I paid for. So the idea is essentially to be able to replicate whatever is the logic, business logic or front-end logic or the storage or database or the external integrations that you have used, so that there is a high availability and redundancy in the system. Now we will talk a little bit about routing. So if you have multiple of these services, how does the request flow from one to another, right? And so in the typical use cases, there is essentially something called as the load balancer that starts coming in between a front end and a back end, between the user and the front end, between the back end and the storage, between the back end and the external integration as well. So the load balancer is responsible to take a request that is coming in, and maybe in a certain algorithm, which could be round robin, it could be least used, and you can apply various different policies, and it should be able to take a request, use some algorithm to decide where it should be routed and route it to the right places. So for example, from front end presentation layer, I should be able to route the request to one of these three, and one of these three based on a criteria that I choose. I could choose, for example, the least loaded server, or the least used server, or just random allocation of this request going to any one of these three servers. And either three of them is a good strategy to make use of, provided I understand what my application needs and how it should work. And load balancers are essentially a good way to be able to dictate or put in rules on how a particular request must be routed to a computing resource. All right. So this is usually what we see in a typical cloud production deployment. The next thing we will be talking about is monitoring and auto scaling. So what ends up happening in many cases is that how do I know? Like, sorry, was there a question? Was there a question from someone? Okay. I'll request whoever is speaking to go on mute, please. Okay. So imagine, like, suddenly you see more number of users who are trying to access the system. How do you then make sure that the system will continue to work? Because it should not get overwhelmed, right? So you can think of it as for example, uh, a simple highway kind of an example where cars are sort of coming into the highway, and the highway obviously has capacity. It has 3 lanes, correct? So sorry, was there a question? Uh, Ganpat, can I request you to mute the person who's speaking right now? I think by mistake they may have turned their mic on. All right. So how would you suddenly start to manage this traffic if you have a 3 lane highway and you need to be able to balance the traffic into proper lanes so that the traffic is streamlined? And this load balancer is essentially a very similar problem. The concept of a load balancer and the kind of problems it solves is very similar.
அது மாதிரி சொல்லலை, அவங்க போட்டோ மட்டும் தான் கேட்டாங்க. போட்டோ மட்டும் எடுத்தாங்க. ஃபார்மாலிட்டிக்கு தானே அது.
Sanmuga Prema, please, I have muted you. I think it is disturbing the rest of the session, so please stay muted. Thanks. Yeah. Right. So how can I use the concepts of routing to be able to route and scale, right? And that's the concept that we are going to talk about now, which is monitoring and auto scaling. So what you will see is that the moment, let's say there is additional load that comes in, you saw the transition happening here. If more number of user requests comes to the load balancer, the load balancer can then sort of figure out that maybe the system will not be able to scale, and kick off an automation called auto scaling that will then add one more node into the system, or maybe 2 more nodes into the system, depending on the rate at which the traffic is coming in. So now your front end is set, but maybe you need to do the same thing for your back end too. So all of these things are being orchestrated by capabilities in the cloud computing environment that will add more and more capacity as needed, depending on where the bottlenecks are. And the bottlenecks is being detected by things called monitoring, where a set of parameters are being looked at. It could be rate of incoming requests. It could be the capacity of a certain storage engine. So for example, if you were nearing, let's say, a capacity of a database, and the database was provisioned for 100 GB and you need to allocate a little bit more, you're reaching 95, you can set an automation threshold that says if there is 5% less capacity, then automatically provision additional storage. And so that is exactly what happened here. From 2 storage devices, I was able to provision a 3rd storage device because some automation detected that the storage was going to be less than what I need, and went ahead and automatically provisioned. So this is a very important aspect of this elasticity and scalability that we spoke about, because the way this comes into picture is through automation that is based on constant monitoring that is happening in the cloud environment. And most of these platforms give you capabilities to be able to set those automations up, whether it is in AWS, whether it is in IBM Cloud, whether it is GCP, whether it is Azure. All of them have similar capabilities baked in that allows you to set up these automations and do auto scaling, right? So this is the concept that I wanted to make sure I call out. The third thing around production deployment on clouds is the fact that from an availability, fault tolerance, and global presence perspective. So availability, definitely we said, like, because you have multiple replicas or redundancy built in of each of these applications, the system is inherently available and fault tolerant. But what about global presence, right? And so the global presence side is because you have a similar setup both in the US region as well as in, for example, an APAC region. And you could have a third region in Europe as well, and it would still work perfectly fine. So it depends on how you want to do your global presence strategy. And the cloud computing environment will give you all the key capabilities that is needed for you to be globally present, right? Um, and this is remarkable because what it does is changes the game completely. So because you now have a lot of computing resources at your fingertips, many interesting new possibilities and opportunities start to show up. Now, what I'm going to do is pause for a little bit, and I'm going to look to you for some examples of applications that perhaps did not make sense 15 years ago, 10, 15 years ago, but are extremely relevant right now. So can you please tell me something that you use on a regular basis or you have encountered in your life that you think from a business standpoint, etc., would not have existed if cloud computing wasn't there, right? And because cloud computing came in, these things are now relevant. 15 or 20 years ago, you could never have thought that these things will exist. So can you give me some examples of things like that? I'm going to go switch back to the chat to see if somebody has a. Okay. Yeah. Nobody. So we'll continue. So some of this stuff is IoT, right? And IoT, if any of you uses Alexa at home or Google Home at home, to manage, let's say, lights of your living room, right? Your air conditioning, right? Or garden equipment that sort of does drip irrigation based on humidity or moisture in the soil. Many of these home automation setups use a whole lot of cloud computing to be able to make those decisions of when to turn things on or off, when to water your plants, when to turn off the air conditioner. And this is a very, very big industry, right? Health tracking is another great thing. So your Apple Watch or your Fitbit is all like sort of sending information up to the cloud so that it can do some intelligent analysis of the data. In many cases, like part of the analysis may happen on the device itself, but part of the analysis will happen in the cloud so that it can bring in new insights, etc., from a health tracking standpoint. And these things would not have been possible maybe 15 years ago because cloud computing was either in very nascent stages or there were adoption challenges because of many, many reasons, right? So these are revolutionary changes that have come in our lives. Google Maps is a great example. Netflix is a great example. Twitter is a great example. WhatsApp, right? Meet, the place where we are doing this call now, is a great example. Without cloud computing, some of these pieces of software would never, never have existed. So keep that in mind, right? The next thing I want to talk to you is about the paradigm shift, and the paradigm shift is essentially the kind of story that we spoke just now, right? That many of these companies would never even have existed unless cloud were there. The 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 possibility that cloud brings in usually signals a large paradigm shift, and a paradigm shift is really a fundamental change in the way that we engage and interact with the world, right? So you can take the example of Netflix, or you can take Netflix has essentially disrupted a completely sort of different industry like cable television. Why? Because the paradigm has shifted. Paradigm has shifted because cloud computing makes this far, far more easier to manage, to run than your cable TV. So OTT platforms are essentially a result of a paradigm shift in the world of entertainment that has been catalyzed by cloud computing, right? So the essence is that whatever said and done, cloud technologies are changing how we do things in our daily life, and this kind of a trend is here to stay. Right. I'm going to give a small analogy to help you understand a nuance about cloud computing, right? Imagine that you have to have dinner, right? And in the cloud computing world, we were talking about businesses wanting to get some work done, some software deployed, some analytics run, etc. But I'm going to take you into a completely different analogy where it is you, an individual, that wants to eat your dinner, and you have many choices in your hand, right? So I, let's say, chose a very simple thali, which has maybe three things on my plate, right? And I would like to have some rice, some dal, some roti, and some aloo methi sabji or whatever that is. Now, if I have made up my decision here, right, I have choices, and so my choices are that I could do this at my house. I could essentially take the ingredients that I need. I'll take some dal, some rice, some flour, some vegetables, spices, oil, water. I'll sort of put them all in the right quantities in the right way on a gas stove that I have in my house. And then I follow the recipe, and I essentially like lay it out on the table with cutlery, right? This is the typical process that any household would follow for eating their dinner, right? And this is essentially what we do. Now, the cloud equivalent to this is go to a mobile app, select the food to eat, you pay, wait for the delivery, and then you enjoy, right? And in many cases, this delivery is almost instant because if you were to do this on some Insta uh, delivery platform, it probably is coming to your house within the next 5 minutes. It is much more faster than what it would have taken you from that decision for you to start having dinner to actually getting to a point where it is on your table is probably a 1 hour job here. Whereas when you look at a cloud provided meal, there is obviously very quick things that are happening over here, right? Because you are not necessarily having to go through the pain of procuring the raw materials, creating the dish, right? And doing the whole 9 yards. You're just selecting what you want, you pay for what you want, and you get delivered what you want. So that's the difference between on-premise and cloud. And I hope this example sort of gives you a sense of the kind of difference that we are talking about. The first one is DIY, do it yourself completely. Whereas when you talk about the cloud, pretty much everything is available. It is just you making some decisions and choices and making sure the end result is achieved. Right. So that's sort of the difference. Any more analogies or paradigm shifts that any one of you can share? Anybody who can think like this in terms of differences between, let's say, on-premise and cloud? What are the other examples that you could think of? Anyone? Please feel free to speak up. I mean, if this is not a conversation, it becomes very difficult to learn. So, right, and I would like us all to take some learnings away, including myself, right? And the inquisitiveness from you folks will help me give you some more insights, some more better examples, etc., and the learning will be better. So, please don't hesitate to ask questions. Anyone? Any other analogies that you can give me from a paradigm shift standpoint? None? Okay, I'll give you a hint. What about music? Does anybody see a change in how we consume music today? Nobody sees the change? Like, do you have cassettes or CDs in your home anymore? I mean, at some point they were all like very prevalent in our houses, right? Does anybody still have CDs or cassettes in their house? No, right? So why is that? Because a huge paradigm shift has happened, right? And no longer are you buying and storing cassettes or CDs in your house because it is irrelevant almost, right? That many of these things are available with your Amazon Music subscription, or your Apple Music subscription, or your Google Music subscription, and maybe in many cases it is even free. So the fundamental sort of business has shifted from a model which used to be extremely physical in nature, where you had to go and buy a CD to be able to listen to the latest song that you like, versus now it's instant, on demand, available at your doorstep. You can just rent it, and on an annual basis, you pay some subscription money and you're able to hear this. It's actually win-win for everybody, right? So this is a great example also where there has been a significant paradigm shift. And again, because of cloud computing. Use of public infrastructure, right? So another hint, another example, anybody can think of some meaningful analogies in terms of public infrastructure? No? No one? Okay. How did you commute earlier? I mean, I usually, if you don't have good public infrastructure, you're essentially going to buy a vehicle for yourself, right? So you will either buy a car or a bike, and then you're going to drive it yourself to wherever you go in the day. But let's now say that there is a facility for you to leverage what is called as, let's say, Uber, where you have carpooling facility available, where you can actually pool the car with multiple other people who are traveling to the same place, and therefore this is bringing in more efficiency into the system, right? So if you were to take the car alone, I mean, obviously, if it is your car, you are paying the entire petrol fee yourself. If you are renting the Uber car, you are probably ending up paying a good amount yourself, and because of a driver who's sort of driving the car too. So there is a reasonable amount of cost there. And then the third option is that the same car is leveraged by four people who are sitting within the car going to the same place. And what ends up happening is the fact that, oh, the cost of the fuel and the cost of the driver driving the car is split one fourth amongst the four people who are traveling. So in some sense, this has become like some way of doing public transport, right? That when you go into a bus, the fact that the bus ticket is so cheap is only because the bus is able to take you from one place to another by sharing the cost between hundreds of people. So I think public infrastructure is a great example of how cost sharing model across hundreds or thousands of millions of people actually benefits the entire society. So cloud computing is a classic example of that, because again, you are accumulating or aggregating demand in terms of being able to offer this as an aggregated demand vehicle, just like how buses are essentially designed for aggregated demand of at least 100 people going from one place to another place. So you have to think about it in that way for you to understand the benefits of cloud computing. Right. So I think we are done with this, more or less. Yeah. Now let's talk a little bit about cloud computing models, and there are a variety of different models that are available for an individual or an enterprise to make use of. It depends on your need, your budget, right? And there are multiple options that are available. So one of the most common clouds, right, is of three kinds. One is obviously a private cloud, which means that it has complete control and ownership of the enterprise. So nothing can talk to it. Nothing is reachable in that environment. It is only locked down to a very specific set of a boundary, right, where it is available. Very high security requirements. Usually, small enterprises will not have a private cloud requirement because they just can't afford the amount of control that is needed, right? Because it needs people, manpower to be able to run such a offering. So usually you will not see small enterprises do this unless they are mandated by regulatory or sovereign constraints where they are forced to do that. Usually you will not see small enterprises adopting a private cloud. So if you want to access the cloud, you will typically VPN in or virtual private network in to this network and then be able to access the resources. It needs very, very high level of technical skills. So unless you have deep technical skills in your organization, running a private cloud is almost next to impossible. And usually you will see government agencies, healthcare providers, banks, businesses that are dealing with sensitive data, medical records, etc. Right? So those are the kinds of businesses that will opt for a private cloud. There is the second kind, which is basically public cloud, and usually this is run by third-party providers, makes use of shared resources, and public cloud is the kind of cloud computing model that we have been talking about till now, where a large, vast amount of resources are being pooled for us to run our workloads, right? So there is no upfront cost because if you as an agency wants to do a little bit of or an enterprise wants to do some analytics on a data set, right? You don't have to buy a large machine with GPUs, etc., or a large number of machines with large number of GPUs. So the upfront cost that goes into buying these resources is humongous. But if you have somebody who can offer it to you on rent or for a subscription, then there is really no upfront cost. So it is based on a usage model. How much ever I use it when I take it from you on rent or take a subscription from you for that particular resource is how much I pay for it, right? So from that standpoint, the upfront costs are minimal because I don't have to end up buying that and keeping it with me. Obviously, because this is pooled and available to me on demand, there is a super agile way, an elastic way of getting things done, right? I can access it over the internet. There is no security requirements of it being locked down and no VPN requirements for it to be locked down, etc. Uh, it is very flexible in terms of cost because the cost is only charged based on how much I consumed. If I borrowed that GPU and I used it only for 4 hours, I will only get charged for 4 hours. Unless I reserved it for weeks and I finished in 4 hours, in which case I'm paying extra money for nothing. But the cost flexibility on how I want to be charged is completely up to me. And I know my problem statement. I know how much time I'm going to make use of this environment, and therefore I can make a logical, knowledgeable call to say how should my cost be structured? Should it be structured per hour? Do I want this for a week? Is my project going to last for a month and I should get this for a month? All of these things are considerations in terms of how you want to decide the cost model for your project, right? So and the fact that this is on the public cloud means that the public cloud is doing everything possible to keep the applications latest, the infrastructure latest, etc. And so you get the benefit of being able to use new things in the platform. The last option is hybrid cloud. And one of the key things that you have to understand is that what this does is bring in flexibility into how you deploy, which means that in some cases, right, I have certain use cases that are very sensitive in nature, and the government is mandating me to do this in a particular way. And so therefore, I will pick that particular use case and put it on private cloud. But another use case that I have does not have these considerations or constraints of the government regulations telling me that it cannot be done on a public cloud. And therefore, for those use cases, I will do them on public cloud. So the fact that I have flexibility in deciding different workloads going to different kinds of clouds is essentially the concept of a hybrid cloud. So uh, uh, many companies, right, have some mission critical applications and some sensitive applications that need to be very safeguarded. Whereas there are certain other use cases and departments within their companies that don't have such requirements. So it makes a lot of sense for such companies to be able to have a hybrid cloud deployment, and that is the kind of model that many companies are now starting to pivot towards. So let's just do a quick quiz and see if we understand this concept right. So I'm just going to give you an example of a company, and you have to tell me what kind of a cloud deployment do they have. So you have to pick between the three over here: private cloud, public cloud, hybrid cloud. And based on the examples that I gave, you should be able to make that judgment call very quickly. So the answer I'm expecting is, against the company that I call out, what kind of a deployment will it have? Will it have a private cloud deployment, a public cloud deployment, or a hybrid cloud deployment? Quick info, right? Everybody goes to this website. What kind of a cloud deployment do they have? Anybody wants to take a stab at it? No one? That is strange. I didn't see a single response. That is very disappointing. Come on, somebody can give me an answer. No one? Okay. Okay, so the answer is obvious. It is public cloud. So Quick Info being something that is does not deal with sensitive data. Cricket is a sport that everybody, I mean, all over the world looks at as news in some sense, right? So there is nothing sensitive about it. Times of India is again news. So obviously will be public cloud, right? RBI. This is the Reserve Bank of India. What do you think their deployment looks like? Obviously, it is a very constrained environment. They are probably making very huge sovereign decisions about the financial stability of our economy and banking sector, etc. Uh, Obviously, this is sensitive information and data, and you don't want that to be on public clouds. So yes, the answer is private cloud. What about UIDAI or Aadhaar data? Where do you think that sits? Is it public information? No, it is accessed publicly when you authenticate yourself. But is it public information? No, it is extremely sensitive information. So where do you think this goes? Public cloud, right? Is that right? Where does sensitive information go? No, it doesn't go to public clouds. It is actually a private cloud. So you've got to have a clear sense of understanding of where sensitive data must go, and the answer is very obvious. So if it is sensitive data, you are mandated in the sovereign rule book. It's a law that your data must sit within a private cloud, within a particular region, etc. And so there is a lot of compliance and regulatory oversight on many of this. What about Airtel? Airtel, the mobile company, and they obviously, because they are mobile, they have a large data deployment. They also deal with sensitive data, but then they also do many things that is not of a sensitive nature. So, for example, they may run marketing campaigns, etc., etc. So, what do you think their deployment is going to be? So their deployment is likely hybrid because portions of their business probably deals with sensitive data, and therefore there will be governance on where that data sits, etc. But many of the things that they do, like from an advertising standpoint, marketing standpoint, could very well be something that can go onto a public cloud too. So the answer probably is hybrid cloud, right? Yeah. So right. So let me take some examples of examples where like multiple options can be chosen. So banking is a great example. So HDFC Bank, their core banking department will maybe have their deployment obviously in a private cloud. Their marketing systems will probably have their deployments on a public cloud. But then the system that stitches things together, right, and basically says that I will take some phone numbers and be able to send WhatsApp messages to that person to notify that person about an offer that we are launching, is a combination of core banking and marketing systems. So those tend to be hybrid cloud, because obviously there is an element of two things that you are doing. You are sending them a WhatsApp message or a SMS message, which is transgressing your private cloud, right? In some sense. So there you have to make use of public clouds to be able to send this information. So you will have many organizations that will choose, depending on their workloads and kind of work that they do, different kinds of models of cloud deployment. It could be private only, it could be public only, it could be a combination of private and public, which is hybrid. So this is hopefully a good example that helps you understand the difference between private, public, and hybrid cloud deployments. The next topic I want to cover is categories of cloud services. Uh, and when you choose a public cloud, right, there are in terms of services that the public cloud offers, there are multiple categories that are available to you as an individual or as an enterprise. Right? You could be a business user or a consumer, right? You are essentially looking at software at that point, which is just something that works out of the box. You are probably looking at Gmail or Dropbox or WhatsApp or maybe Office 365. So as business users or consumers, this is something that you may be looking for, which does a job for you, right? As developers, you may be looking for something else. You are going to build this software like Gmail, like Dropbox, like WhatsApp, and you need the fundamental building blocks that can help you build that software. So what's that? That is maybe a platform that provides you the databases that you need to be able to run a service like Dropbox or Gmail or WhatsApp. Or it could be tools that help you deploy the application that you have built on the private cloud, on the public cloud, sorry. Right. And so there are tools that will help you push your code changes into the public cloud. So that could be something that you are interested in, or it could be even runtimes. So, for example, you could take an AMI or a Amazon Machine Image on EC2s for EC2s to be able to set up the operating system on which the application is going to be deployed. So that's the runtime. So it may have Java, it may have Linux operating system or Red Hat operating system or CentOS operating system. So you choose all of these things as a developer based on your application and the kind of things that you want to do. And the development environment on these public clouds will give you these tools and capabilities for you to leverage and do these activities in a very fast manner. The last one is system administrators. What are they doing? Right. So these guys are looking at computing resources, network, storage, virtual machines, etc., etc., etc. The hardcore infrastructure side of things, right, is what these guys are looking for. So cloud services cater to all these needs. So really, the one that addresses the system administrators' needs is infrastructure as a service. So, or IaaS, which is all kinds of computing resources, storage, right, VMs, network-related capabilities, load balancers. These are all things that are available to you as infrastructure. The other thing that also the system administrators want to run and deploy is their databases, etc., etc. Right, and so that's the nature of infrastructure as a service. But as a platform as a service, this is everything that you need from the ability to deploy a product or an application. The whole thing shifts, right? So you are essentially now consuming the operating system that was provisioned by the system administrators, or the database and storage that was provisioned by the system administrator. And you are essentially making use for these services as you go. So you project out saying, I'm going to spin up this much amount of storage for storing, let's say, 10,000 photographs, based on which I'm going to run some AI modeling exercise, right? And for that, I need 500 GB of storage, and I'm going to pay for that 500 GB for 1 week. So that's something that is available to me as a platform, as a service. Once it is provisioned, maybe you're going to store this on an S3, and the bucket details will be provided to you by your infrastructure team. And then you can essentially start using it and leveraging it to build your product. The last one is as a developer, what am I doing? I'm just creating software. And once that software is ready, I should be able to install it, run it, manage it, everything that happens from, and scale it also. And remember, we saw that example where we showed load balancers, and based on incoming traffic patterns, we are running automations to auto scale the environment. So all of that is sort of part of the software as a service, or SaaS category of services that are provided by cloud providers. Right. And so again, we will go back to our example of how we were looking at dinner, right? And right, you if you look at that whole process of dinner making, you were cooking at home, and there were a bunch of things that you needed to have, right? So prerequisite was serveware or cutlery, table, drinks, a gas or a stove, recipe to make whatever you are cooking, spices to spice up the food, the vegetables that you need as raw material, dal that you need as raw material, and rice that you need as raw material to cook your dinner. Right? The sort of ready to cook option is slightly different. You probably just need cutlery, table, drinks, and a gas stove. All the other things have been taken care of because maybe you decided to go and get a packet of Maggi. And Maggi, obviously the good Maggi with all the vegetables and atta noodles and everything. But once you brought it, this is a ready to cook package, and the only thing you need is a gas stove, maybe drinks to be placed alongside the Maggi, and a table and cutlery. Right. So when you look at the home delivery side of things, you are just looking at cutlery and a table. And when you finally, like in the final option, when you just look at to say, look, I'm just going out and I'm going to eat something out and come back, you don't even need that cutlery and the table. So in each of these pillars, your requirements on the system are shrinking. And essentially, that's the value that some of these cloud services provide. So if you were to think about it in the on-prem world, if I were setting this up myself, I would have had to deploy a network. I've had to provision storage and allocate storage and buy licensing for that storage. I would have had to go and buy servers on which I would deploy virtualization software. And I would have purchased virtualization software prior. On this virtualization software, the VMs would run on a certain OS and a certain middleware and have certain runtimes, on which I will then sort of deploy my data and applications. So I would have had to do everything, correct? But in this world, I'm looking at forgetting about networking, storage, servers, and virtualization from a infrastructure as a service point of view. The only thing I'm worrying about is the operating system, middleware, runtime, data, and applications. And when I look at the platform side of things, even the requirements for operating system, middleware, and runtime are gone because I'm just going to leverage something that already exists in terms of runtime, in terms of middleware and operating system, and just focus on what my product does, which is probably building applications on top of some data, right? And in the last one, right, for everything that I was doing, a SaaS product already exists that I can leverage. So I don't even need to build an application and use the data that I have. I just need to leverage that application with the data that it provides and just get my job done. So if you think about it, this is sort of the parallel between the way you think about your dinner and how you think about cloud services. And I hope this example sets the tone for understanding, right, what the differences, key differences between on-premise, infra, IaaS, PaaS, and SaaS are. So that's the idea. Um, the next thing we will talk about is in some sense like a visual view around advantages that cloud computing brings in. We will go from 1 to 10, right? And just sort of enumerate them. We don't want to go into each one of them too much in detail. But less cost, we have already spoken about it. 24/7 availability because of redundancy, etc. We have spoken about it. Flexibility in capacity, and we have spoken about being able to scale up or down depending on the traffic that is coming in. All over functioning, the ability for us to keep things up and running, always operationally not too complicated always, right, is essentially what is this functioning side of things. Automated updates on software, right? And from a perspective of managing the environment, the ability for us to be able to keep the environment up to date because maybe there was a patch that needed to be deployed on the operating system or on the database I make use of, right? All of that stuff, because now it happens behind the scenes and we don't need people to actually sit and configure those updates and run those updates and wait for those updates to finish. It all happens automatically, makes this life very, very advantageous for us. Cloud security is another great thing that comes bundled within the cloud itself. And part of this update software, etc., things is broader security gamut. Carbon footprint reduction. If I were to run this data center myself, the amount of electricity, the amount of AC cooling that needs to be provisioned for the data center that I spin up myself is substantial. The smaller the data center is, the larger the power requirements on an average. So the bigger it gets, you can then use scale, right, to be able to deal with things in a much better way. And therefore, naturally, by getting into the world of cloud computing, we are reducing the carbon footprint. Enhanced collaboration, control on the documents, easily manageable. I think these are self-explanatory. We can probably skip some of these. So there are a few essential concepts that I want you to carry in terms of food for thought. Just think about what would be the average size of a cloud deployment for a small business. So take any small business near your house. How much, and when I say small business, let's say somebody who's doing a business of, let's say, at least 5 crores or so. What kind of a typical size of the deployment do you see for a small business, right? And what kind of challenges do you think will arise? So the first one sort of promotes a little bit of curiosity in your mind on how many, let's say, computing resources a typical small business could be running. How many applications could they be running? And what kind of challenges do you think will arise in the because of whatever size of the cloud deployment that a small business needs to manage? If anybody wants to take that question, I think I will very happily let you take that question and speak up. What do you think the average size of a typical cloud deployment for a small business will be? No one? Okay, so usually this would run into hundreds of servers, and maybe early 20s in terms of how many applications that they need to sustain their system. So you can imagine this is just one small business, right? And that person has to manage 100 servers, deploy code to 100 servers, and manage all these nuances very carefully. It's a tough ask, and in terms of challenges, obviously, the ability for him to be able to maintain such a large deployment, even for a small use case, is actually quite scary, right? So that's where I think the whole thing about uh, complex activities in the cloud, because now suddenly, because you have hundreds of resources, you start seeing that security becomes a very big challenge, and you have so many different machines. And what if one of them gets hacked and some data is leaked, and so on and so forth? So security in the cloud becomes extremely paramount. And usually public cloud providers will share the information that is needed for securing the infrastructure. They are responsible for a huge portion of it, but also the customer themselves are. So the customer who's making use of these cloud providers must also do many things to make sure that their data is secure. So one of the few things that typically are to be looked at is data encryption, both at rest and in motion. What do I mean by that? The fact that data encryption, when it is on the disk, the data should be encrypted, is what is called as data encryption at rest, right? When this data is being shipped from one place to another and it is going over a network, there that data needs to be encrypted too, because on the network, if there is a man in the middle, he can just pull this information out and access and see what that data was going, and potentially even tamper with it. So from a security practices perspective, data encryption becomes a very key requirement for security in the cloud. Same goes for identity management and access authorization. So unless you have this, how do you guarantee who's got access to the data, right? And that is a very key aspect of maintaining security in this environment. The takeaway here is that the responsibility just doesn't stop at either the cloud provider, nor does it stop at the customer. It is a shared responsibility that every customer and the public cloud provider must cooperate and make sure that the shared responsibility is being done justice to. That whatever needs to be done by the customer is being done by the customer, whatever needs to be done by the cloud provider is being done by the cloud provider. Right. The second interesting thing to think about from a critical thinking standpoint is that once a small company starts doing maybe hundreds of servers, that means that public cloud deployments, I mean, for larger organizations could span maybe tens of thousands, right? This could be hundreds and hundreds of applications. Very, very hard to maintain such complex systems. So what do you do? So then we lean on some first principles. And one of the things that is in vogue right now is this whole concept of cloud native. And cloud native is a set of principles, guidelines, and processes to sort of manage this complexity. And what it does is that is essentially that it is allowing us to look at the various deployments that we have and find out ways in which we can reduce the effort that we put in to maintain many of the things that we just spoke about: security, deployment ease, monitorability, right? The ability to do a quick disaster recovery into a different site, the availability for us to, within a site, be able to do some kind of fault tolerance by leveraging load balancing, etc., and achieve a purpose where the system is highly available, even though it is within the same availability zone. At the very least, it is highly available. Correct. So those are the kinds of things that we would like to do. Some of the key technologies that are starting to come up now are and supporting the cloud native architectures are containers. And can anybody take a stab at like understanding or help me understand what containerization is? Anyone? No? Okay. I'm hoping that you are aware of what virtual machines are. Virtual machines are essentially a layer above the operating system, a very thick layer but above the operating system that has a way for us to be able to manage the infrastructure, right? When it comes to compute, memory, etc. I think one of the things that is changing in that domain is the fact that the new normal is containers. And containers is an interesting concept. And containers is an interesting concept because it takes the concept of VMs to a simpler logical level, which is that within a particular operating system itself, I should be able to isolate the traffic, isolate the traffic, right? That essentially is uh, processes, etc. Right? So in a VM, we have many different applications that are running as individual hosts or virtual hosts on the operating system, right? In the container world, there is only one host, and then you are partitioning the traffic of different applications into segregated and independent units by virtue of slicing them within the operating system so that they are completely isolated. So this is a much more lightweight way of dealing with application isolation, unlike virtual machines where we had to separate them out into virtual hosts, and each of them was running an operating system on their own. This is only one host operating system that is slicing that operating systems into different processes that run within their own sandboxes, or to be crude, right? So if in that sandbox you are able to isolate one application with another, you have essentially achieved a very simple form of virtualization in some sense, and that is what containers are. The commonly known containers these days are Docker, for example, or Kubernetes, for example, that takes this to one larger level. Uh, Docker is a simple way of taking a image and deploying it within a container environment. Kubernetes does this at scale and orchestrates this at scale. So that takes us to the second concept of orchestration, where there is a way of managing and scaling containers across the cluster. So, for example, you can say that I want 3 nodes of this application deployed always, and Kubernetes will orchestrate it so that even if there is a fault in one of them, it will take care of bringing it down, bringing up the third node so that there is always 3 running at any given point in time. So, and all of this happens in a declarative manner in the way that the application is being manifested within Kubernetes. There is a way that you can create a document and describe what you want from the system, and Kubernetes will orchestrate it. Right. And those applications that are getting deployed as part of this orchestration layer in the container are really what microservices are. Right. So this is essentially 3 things that you should know. And so the 3 other points that I'm calling out over here is service mesh. And the service mesh essentially is a way that now that you have like hundreds of these microservices and each of them talking to one another, how do you manage the dependencies, communication, security between the microservices? So there is a framework that has been built on top of Kubernetes, right? It's called Istio, for example, and that does a wonderful job of being able to trace what those dependencies are, how things should be stitched up, and what should each service authenticate with the other one as. So all of that stuff is baked into uh, this technology called the service mesh. Continuous deployment and continuous integration is again like some of these things starting to see a lot of automation getting built in, and many of the folks who are adopting container native or cloud native architectures using containers are using GitOps, where you essentially, if you want to push a change, you just check in a declarative YAML into GitHub or GitLab. And then from there, there is an automated trigger that takes whatever you have put in as a check-in now, figures out what needs to happen, and deploys that into the Kubernetes cluster. So that's another thing that is happening in the world where we are seeing a lot of automation that is happening through a very simple code change, where code here really is infrastructure that is being represented as code. right? So phenomenal number of things that are going on there. The last thing I will call out here is serverless computing. Remember, we spoke about infrastructure being allocated, etc. In many cases now, where things are heading is towards this concept called serverless, where there is really nothing from an infrastructure that is being provisioned for a service behind the scenes. It is just some code that needs to be run, and it will run on any compute that is available at that point in time without you having to allocate an EC2 server or some kind of a compute node. So the compute is sort of getting implicitly baked into this concept of serverless computing. So that's an interesting way of looking at it, because now you don't have to manage the server. You don't have to patch that server, because really the only thing you own is that code, right? So it's sort of like that restaurant example where you tend to own lesser and lesser and lesser, and you're just leveraging services that are being provided by the cloud, not having to do much at all. Right. So this is basically the future of cloud computing, serverless that we just spoke about, edge computing that is starting to become interesting because there is some amount of edge, and this goes back to that client server architecture that we were talking about, where some amount of logic was getting done on the client. I think edge computing is merely an extension of that same concept. AI and ML services, with recent developments on large language models, etc. Many models and services are now available out of the box for deployment and use. And finally, I think quantum services, where quantum computing devices are also being offered now through timeshare, etc. basis, for anybody to be able to make use of and pay for, like maybe a short time slice where you can submit your workload to a quantum service, get results back, and then the quantum service can be given back to the pool where somebody else who's researching quantum can make use of it. So these are sort of the building blocks of what is coming as part of the future of cloud computing. And I think by the time many of you graduate, many of these things will be physically, like sort of not just like virtual concepts, but like physically being used to the fullest in your environments. Right. Uh, there is one other concept that I would like you to think through on like one thing that keeps coming up, right? Is cloud really cheap? And then there will be a lot of these interesting visuals that are being provided where they say that yes, cloud, which is the on-prem, which is the blue line, is expensive to start, but it becomes cheaper over time, and the cloud costs, which is very easy to start and very low to begin with, becomes very expensive in the long run. So is cloud really cheap is the question, right? And so there is this 3-year mark or around 4-year mark where you start realizing that maybe cloud is not necessarily cheap. And the whole premise was that cloud is cheap, right? So what's the take on this? Right. So the take on this is that yes, there is definitely low starting costs for cloud. For many businesses, that actually makes sense because they don't have upfront too much money to run the show. So no brainer that they should start with cloud. Uh, but then it is also very clear that on-premise seems to be cheaper in the long run. So if you were to run a particular software for 4 years or more, then you should think of deploying this on-prem, is what this visual seems to be indicating to us, right? So clearly there is something to discuss here. But I think what we have to understand is that the benefits outweigh the cost differences. So what do we mean by that? What do we mean by that is that remember that this on-prem stuff is very difficult to scale. That was the whole problem. If the business grows and suddenly we need more, then what happens is you start again from a line that starts upwards like this. Whereas for the cloud one, it will remain pretty much stable and linear, right? If you were to allocate more capacity at this point, then this is going to take a larger, steeper growth upwards, and then suddenly starts becoming more expensive. So, point I'm getting to is that while on a scale where everything is static, yes, a static on-prem deployment may look is inexpensive when compared to cloud in the long run, but there are many hidden things in this that we should consider before we make that decision. So one benefit definitely is that horizontal scalability, scale up kind of a thing that we should consider. Uh, right. The other thing is about everything else, right? Security, reliability, that comes baked in with cloud. So imagine like if you were to do this on-prem, you would have had to have a team that is constantly patching these servers, because you cannot have any vulnerabilities that leads to a security loophole. The moment you start doing things like this, anything that you have on-premise is going to incur an additional cost. And so if you factor that cost in, then you will realize that, oh, I mean, this is an expensive bargain, right? So I thought on-prem was cheap after 4 years, but no, I'm having to do these four other things for which I need operational staff. I need some developers to be able to do this work. And so when you factor in salaries, etc., for those people, the costs suddenly go up again. Also, like every 4 years, your the hardware that you procure for 4 to 5 years, right? The hardware that you procure for on-premise will become end of life. It will not be supported, and you will have to go through an upgrade cycle where again this cost goes up. So people may say that in the long run, on-premises may be a little cheaper, etc. But I think you can take that with a pinch of salt, because it's a very black and white statement. There is a whole lot of detailing that needs to happen to make that determination. In some cases, maybe it is cheaper, but in the broad majority of cases, when you factor in scalability, security, the fact that you have to do maybe over 5 years, you have to renegotiate contracts for hardware, etc. When you put all that together, uh, I think like there is no clear evidence that on-premise is cheaper than cloud. So I will leave you with that thought. Uh, Generally, I think from a adoption standpoint, it is significantly lesser headache to just opt for a public cloud deployment rather than on-premise. But if you have specific use cases around security compliance, regulatory pressures, then organizations may want to maybe evaluate on-premise, right? Yeah, I think that's it that we had for today. And I'm going to maybe pause a little bit to take some questions from everyone. Okay. I just see one answer from Pranav sometime back. So good. Any questions from anyone? We are closing the end of the call. So closing on the 2 hour window. Anybody has any questions? I can take them. No questions from anyone? Okay. Is this all something that you are already aware? I don't know if so all of you are from the same batch, same years, and have you done some courses on public cloud, private cloud in the past? I'm assuming maybe you have this covered before, so which is why there were no questions. But when any kind of feedback will be good. Okay. If there are no questions, then I think Ganpat, we can maybe stop the recording. And ah, what is the use of AWS in developing apps? So goes back to this slide, and if you're able to see this, right? Yeah. So you can decide. I mean, your applications could be I mean, really, if you are building an application, you are sort of in this territory, right? That in the third pillar here, where you are utilizing AWS as a platform as a service, where AWS will give you the runtime, middleware, operating system, virtualization, servers, storage, network, etc. You just bring your data and the application that you want to deploy. Now, from a application deployment perspective, they may have some tools that are available. In some cases, they have services for developers. Like I think there is a service called Code Whisperer that helps you write code as well. So AWS has a service where you can use AWS's Code Whisperer service to just describe what you want the code to do, and it will actually write code for you. So it will help change your code from one language to another. So if you are developing an app, you can potentially like very easily provide some inputs to some of these services and accelerate your development time. So AWS has many things available that will help uh, the developer in getting their work done faster. So I hope that answers your question, Pranav. And I see Sanika that says, what are the benefits of using hybrid cloud model? So hybrid cloud model, there is benefits in the sense that uh, from the perspective of an organization, right? It lets you choose between the two. So you can it's not one or the other, it is one and the other. So that's the notion of hybrid cloud, that you can have certain things on premise, certain things on public clouds, and sort of bridge it between the two, right? So you can share some data to build some applications which then can do broader things, etc. And I gave some very good examples in the examples that I had taken, right? So like HDFC Bank, for example, their core banking system will not use anything other than private cloud. Their marketing systems will not use anything other than public cloud. But if there is a use case that has to send marketing notifications to HDFC core banking customers, then potentially they can leverage the this whole thing around hybrid cloud and make use of both of these systems to get that work done, right? Won't it affect the security? So again, this is use case based, right? So it will actually be much secure because the use case is applicable for this kind of a model. So what I mean by that is the fact that uh, let's take an example of the kind of data that is going to be available, right? So there may be this application that we built, right? This bank user code notifications application. This may have a small piece of code that is running on premise. It talks to a public cloud service. So it talks to the core banking service within the HDFC intranet or whatever their network is. So it is secure. What it has is approval to be able to share maybe one bit of information, and that is probably just the phone number of the user, right? Or some very limited bits of information that can then be sent to, let's say, a service like WhatsApp. And the user is going to agree to certain norms. He says that I'm accepting user notifications, etc. So from a compliance standpoint, we have done everything that is needed from a agreement standpoint with the user that his information is going to be shared with him through WhatsApp or her through WhatsApp, and therefore that's a approved way of notifying the user. But at the same time, the communication between the HDFC intranet server and the cloud offering will happen through, let's say, HTTPS or an SSL channel that is completely secure, right? And will have all kinds of authentication like mutual TLS, etc., to make sure that between the private cloud and the public cloud services, the communication is happening over a 100% encrypted channel. So therefore, I think you can build some levels of trust within the system that the security will not be compromised. So I hope that answers your question, Sanika. Does the lack of reliable, stable internet speed cause much problem in cloud computing, or is there a solution to it? I mean, it is. It is definitely. And as you start looking at services that are doing operations over large volumes of data. I mean, data could lie on one system and another system, and you want to bring that together to do some analytics. Definitely, there is going to be problems with latencies, right? User experiences suffer because of latencies, and so part of it will have to be handled by architecture, part of it will have to be handled by design. So it is very important that you understand that you just can't start adopting public cloud. You have to have the necessary architecture for you to be able to work with cloud computing and public clouds, and also understand that this is a very different environment than let's say on premise, where everything used to be in one place. These set of services could be vastly decentralized, could be in different regions, etc. And so challenges that cloud computing brings in are all very, very interesting. With recent advancements in networking and now having 5G and going to 6G, etc., many of those things are probably less impacting today than they were maybe 5 or 10 years ago, but is still definitely a problem when it comes to uh, very low latency operations, etc., and have to be thought through very, very carefully. So till date, I think some of the most sensitive low latency applications will be things that happen on the stock market, for example, right? Very, very quick decisions on when to buy, when to sell have to happen within microseconds in some cases. So some of those systems do definitely need to consider the fact that the internet speed may not be reliable, etc. So you have to make sure the architecture has all the supporting things in place for such systems to work in a predictable manner and in a manner that user experience is not compromised. So it's not a very simple answer to your question, Pranav, but in some of the conversations that we have in our architecture session, we talk about some of these problems in a little more detail. Maybe when we get to that session, some of these things will start becoming a little clearer. Okay. Any other questions from anyone? Okay. I think, okay, one more. When company thinks they should have their own server, use one's cloud. And I think we covered this one also, right? We have talked about it, right? This is that private cloud versus public cloud difference, Pranav. When do you think they should have their own server or use their cloud? This is that differentiation. When you are being regulated by let's say the government, you are dealing with healthcare data, you are dealing with sensitive financial information or individual information, you are dealing with identity information. All of these are situations where you should definitely think of your own server in some way, or you can use a public cloud, but the architectural requirements will start to become very important to consider. It's not going to be a typical public cloud deployment. You have to have a lot more in that public cloud deployment to be able to deal with data like this, right? So it has to be within a certain region. You have to follow certain standards of encryption, certain controls that need to be put in place, etc. So at that point, the organization may decide to make a decision whether doing it themselves is cheaper or going to public cloud and doing all the certifications that is needed is cheaper. So it's a trade-off that enterprises will have to make. Okay, one last question, maybe, and then we will sign off. If there is one last question. Okay, I think since there are no questions, let's just close the bridge. Thank you everyone for joining, and thanks for the questions at the end. I wish there were more questions during the conversation, but I'll take what comes my way. So please participate more in some of these discussions, and it will be a good way to learn more. But thanks for some of the questions towards the end of the session. Thank you.